Welcome back, everyone. In this video, I'll begin going over the lecture for the area between curves section. Now, the idea with the area between two curves, and pretty much the idea with any application of integration, at least until you get used to it, they're very visual. And what's going to happen is that in a lot of problems, especially when you're finding areas or volumes and things like that, you really need to know what the picture looks like to be able to set up your problem. So a big thing in this section is going to be when you're presented with a problem, really the hard part may not at all be doing the integration. The hard part may be setting up the integral. But really that's the new thing, is because once we set up the integral, we're just integrating like we have been for quite a few sections now. You may use substitution method, you may not, you may just use the direct formulas. But that's just one thing to keep in mind. And one thing I will do in all the problems is, and there's actually a little hint on every problem just to reinforce the idea that you should be drawing the picture or using a graphing utility to see the picture. Okay, so with that said, we'll go ahead and talk about the idea and build up the formula for the area between two curves. Now, this is sort of a setup of a picture of what you would be looking for. So if you were asked to find the area between the curves y equals f of x and y equals g of x, the y equals f of x is on the top here, y equals g of x is the one below, and we were finding it between x equals a and x equals b. So that's what these green dashed lines really symbolize, is that we're cutting off the region we want to find the area of. Well, I use R for region. Some people might use A for area, which is fine, but usually we describe finding the area of the region. And we would want to find this area. And the idea here is that in order to find this area, we have to do a couple things, but the one thing I'd want to really start off with is that you need four things to be able to find the area. You need to have the two equations. So we need y equals f of x and y equals g of x, whatever they happen to be for our problem. And we need the bounds of x. Now, we'll see in some problems that you'll be told what x values to find the area between, and sometimes you'll actually have to figure them out yourself because the way the curves would graph, they will actually intersect themselves. So in some problems, you'll only be given two curves, and we'll see how to deal with that as well. All right, so just want to quickly build up the formula for the area between two curves. The idea and all these formulas really that we talk about applications of integration, they come from visualizing the rectangles and doing a Riemann sum. So what I did is I went ahead and took this region here and I made a left bound, so left endpoint for rectangle approximation, just so you can visualize what's going on. But the main thing here is that when you're dealing with these rectangles, they still have the same base. So it's b minus a over n for how many rectangles you're choosing to do. And we know with the Riemann sum, we have to take the limit as n goes to infinity to get the exact area. So just for visual purposes, I only drew 4. The main difference here is that what is the height of these rectangles? Well, I'm just looking at the second one here because I think it's the easiest one to look at and see what's going on. But the height of the rectangle, I chose the left endpoint, so I'm looking here. And I label this point as xi. So I don't know necessarily what the x value is. It might be the first one, but it might be the 10th one. I'm just drawing an I for that. And the function value here, the top is the f of x function. So this is f of xi. And the bottom, so where the rectangle really begins vertically, is at g of xi because the bottom curve is g of x and it's at xi. Well, what does that mean? That means the height of the rectangle here is exactly that. It's f of xi minus g of xi. And when you compare the difference between this picture and the picture of just the definite integral, you have that the height of the rectangle is just f of xi for the regular integration. But really that's the only thing, because when we set up our Riemann sum here, we would say the area of this region, we take the limit as n goes to infinity to make infinitely many rectangles. And then we have the b minus a over n. Hopefully you remember that, but that is the base or the width of the rectangle. And then the f of xi minus g of xi is the height. Now you might recall that there are formulas to write down xi. It's like b minus a times I over n plus a or something like that. But we know from past experience, we don't actually have to write that down because it all goes away anyway and turns into an integration. So I just left it as xi. But the point here is that this is the area of the rectangle. And when we take the limit as n goes to infinity, what happens when we do the area of infinitely many rectangles is that becomes our integral. And the only difference here is what's right here. Instead of f of xi, it's f of xi minus g of xi. So when it becomes an integral, inside the integral, instead of having just f of x, you have f of x minus g of x. And this is the formula we really want. So it says the area of the region between two curves, and that's the incorrect spelling of 2. So TWO from x equals a to x equals b is given by the definite integral from a to b of f of x minus g of x dx. Now, there's a very important thing about this formula, and that it's also in the way I drew the picture. It's that f of x is bigger than g of x on the entire t of a to b, so it's always above it. And it says, if the functions cross, then you may have to set up a more than one integral. Right. So one thing that might help more instead of just having f of x and g of x here is if you replace this, and this is up to you, but if you replace this with the top function minus the bottom function, because they can change, dx. So f of x is the top, g of x is the bottom for our picture, but in general, you might not have f of x and g of x anyway. You might just have two equations. They might use like h and w of x or something like that. So just really knowing that you're doing the top minus the bottom is what's important. But one thing I wanted to write on the side here is that what happens if they cross? Well, the general formula for the area between two curves, we don't typically use this just because when you see it, it's easy to get stuck, but you might see it written as a formula and you might need to interpret it as an area or something like that. So it's the integral from a to b of the absolute value of f of x minus g of x. So let me go ahead and just kind of really point out that this is an absolute value. You won't really use this, but it's just so you know that it's there. And the basic idea here is if you have your two curves, I'll just draw a little sketch. And let's say x is a is here and x is b is here, and they cross. So at some point, this is y equals f of x in green. And then in purple here, we have y equals g of x. And we want to find the area between those two. Well, then we have to find from x equals a to x equals b, we would want to find the area of these two things. But what happens if you don't include the absolute values is over here where f of x is bigger than g of x, the height of the rectangle is positive. But without the absolute values, it would be saying that the height of the rectangle over here is negative because f of x would be smaller than g of x. So what this does, the absolute values do, is it makes sure that the heights of your rectangles stay positive. And as a result, the area stays positive. But the way we'll do it in a problem, as we'll see very quickly, is you figure out where they intersect and you set up two integrals because we can't actually integrate with an absolute value. In general, you set up multiple because they could intersect more than once, which we'll see. Another thing we'll also see very quickly is you can find the area between two curves. I had another typo, the same exact typo as before there. You can set up area between two curves with horizontal rectangles if the functions are written as a function of y. So what I mean is that if you have like x equals 4y squared and x equals cosine of y, you can actually graph these just fine in Desmos. And instead of looking at it from top to bottom, you look at it from right to left. So the height of the rectangles in this case is right to left. All right, so even though this video isn't long, this is really just the preliminary stuff. And what I want to do, because these problems will take a while, is just do each of the following problems in their own video. So I'm going to stop this here and I'll see you in the next video.